Hi everyone, my name's Carl. Welcome to my channel and welcome to my workshop. This is part 4B of the Harrison horizontal vertical mill restoration, and we're going to see if we can put a thread into this test nut which is made of aluminium. So without further ado, let's get on and see how we manage. Right, well, you've just seen me weld this 8mm steel bar onto the tool. The issue that I had was that despite the fact that I made that cardboard template that you saw in part A, and if you haven't seen that, then I urge you to go and have a look at that to see what I'm talking about. There was a big issue with clearance in the 0.905mm hole in the blank, which led to me having to grind the back out of the shank of the tool quite extensively. So I was already really concerned about the flexibility of this and the lack of rigidity. So I've got almost no clearance at the back, or had almost no clearance at the back, but bags of clearance at the front. So I took this piece of 8mm round bar and welded it on, as you've just seen me do. In the words of Anatoly Stepanovich Dyatlov, that welding's not great, but it's not terrible. It doesn't look pretty, but it's a good strong weld. So hopefully that should stiffen up the tool a good amount, enough for us to do what we've got to do. I appreciate that I've probably gone up the garden path with this thing a little bit, and it might have been easy just to have ground a piece of high-speed steel and inserted it into a bar, but I'd already gone a long way down the road with this thing, so I just wanted to try and use it, see if I could get it to work. Invested quite a bit of time in it already, so a little bit more isn't really going to make much difference. And basically, if I can get it to work, then that's all to the good. It only has to, do it the once, basically. So hopefully it'll work. I have, however, got a plan B. I bought this from Associated Production Tooling in Glasgow. If I can get the camera to focus on it, I think I can. So this is a 5 acme internal threading insert. I mean, Mitch, my friend, did say to me, "Why don't you buy one of those and make a holder for it?" And yeah, perhaps I should have done that, Mitch, to begin with. But I've gone down the road with this thing now, so I'm going to try and persevere with it and see if I can get it to work. If it doesn't work for any reason, or if it causes me problems, I've always got this to fall back on, and I can make a holder for it. Anyway, we'll get over to the lathe now, and we'll get this tool set up and see how we get on with it. Okay, so we've got the lathe set up now with the tool in, ready to try and take some cuts in this test bore. The first thing I'm going to show you about the setup is that we've got the tool square to the work. So I've got the tool squared up to the face of the bore, where we faced it earlier on in part A. So hopefully you can see from that the tool's actually square to the work. Let me just try and get you in closer. There's a bit of glare there, but hopefully you can see that is actually showing us that that's square, the old Moore and Wright threading gauge there. Right, so you can just about see there is my recently broken the glass on it. I'll turn the light off, it's easier. Dial gauge. So that's set up on the tool post so that we can see how much movement we get when we put the feed on, or the cut on rather. The reason that's done is because I've set the top slide over to 14.5 degrees, which is half the thread angle of 29 degrees. And the purpose of doing that is to ensure that the tool cuts on the front edge, because this is quite a broad, almost a form tool if you like. So I want to try and keep the tool pressure down to a minimum. So it'll just cut on the front edge, and the back edge will shave the flanks that the front edge is cut. So that's the purpose behind that. The reason we've got the dial gauge on there is because when you've got the tool post, the top slide set over like this at an angle, you're actually moving the tool through the hypotenuse of a right angle triangle, so the movement is actually greater than it needs to be. I'll explain that to you on the whiteboard shortly, how that affects it. And there's a bit of trigonometry you can do to calculate that if you don't have the dial gauge on, but the easiest way for practical purposes is just to put a dial gauge on so that we actually see the amount of movement is read directly. A bit like a sort of a analog DRO if you like. So the first thing I did this morning when I came in was make sure that feed gearbox was set to L2, because that would be a schoolboy error and a half. and we're set up to run at 40 RPM, but we can adjust that with the DRO, obviously. So the thing I'm going to do now is I'll start the lathe up and I will engage the half nuts, and they'll stay engaged throughout. So I'll bring you back when we've actually got a cut on, and we're seeing how this tool performs in the bore. Okay, this is it. So I'll just put a 2.5 thou cut on using the dial gauge to read that. So this is it. If it doesn't work, you're going to be the first to know. Here we go. Well, it's definitely cutting. Okay, that's the tool out, so we'll back it out with the cross slide, reverse it. Bit quicker, I think, to reverse it. Well, yeah, it's taken a scratch pass, definitely. Stop the machine, back into 0 on the cross slide. And a bit more cut. Put about 3 thou on this time. Okay, and in we go. Yeah, it's definitely cutting. Just wait for it to exit the bore. Stop there. Back the tool out on the cross slide. Reverse it back out. Stop. Tool back into 0 on the cross slide. Bit more cut. It will take a bit more, take 5 thou this time. Seems to be coping reasonably well with it. Okay, and back in we go. Yeah, it's definitely putting a thread in there. I'll try and get you in a position in a minute to show you it. After this cut, I'll move the camera. Okay, that's it out. Back the tool out and reverse it. The other reverse. The reverse that actually makes it go in reverse. Okay, I'll reposition the camera and try and get you a view of what it's actually doing in the bore. Okay, that's the cross slide back to 0. We've got about another 5 thou cut on. I'm not too sure actually if this is a better angle. You can see slightly better. Let's see how we get on. Okay, so we'll take it back into the cut now. So that's a tool clear of the bore. Back back out on the cross slide and reverse her out. Okay, so the tool is clear of the work now, so we come back to 0 on the cross slide, put some cut on, about 5 thou, because that seems to be working nicely for us, and then off we go. Watch for the tool exiting. Okay, that's it out. Back the tool out and reverse it. I'm going to turn that potentiometer the right way one of these times, you know that, don't you? Okay, stop. Back into 0 on the cross slide. Put some cut on. Another 5 thou. Okay, I'll just carry on like that, rinse and repeat, and I'll bring you back, as the saying goes, rinse and repeat, and I'll bring you back if anything untoward happens or when we've got some kind of a decent thread. So we're looking at for a depth of 0.11. So barring any unforeseen circumstances, I'll bring you back when we get to that point. Okay, so it's the next day now, and we have our test blank here, which I've taken out of the lathe. Now, despite everything starting off well and everything going fairly swimmingly to begin with, after I shut the camera off to continue taking passes and hopefully depthing the thread to the correct form and depth and having a nice thread in there, it went drastically wrong, and it became an unmitigated failure. And in fact, I actually stopped and took the piece out of the chuck because it was just obviously not working properly and going from bad to worse. And as you can see there, there's a lot of flank tearing in there. The depthing is not correct. You can't tell very well. I'm going to cut this in half and section it shortly to show you that the root width is ridiculously wide, and the crest width is almost pinpointed. It's actually much worse than the worn one that we're trying to replace, and you can see there that the tool's not been cutting. It's been tearing. It's just a mess, and if I turn it round, it's no better the other side. It's a horrendous mess. So it looks to me as if the tool's been has lost its temper, basically, due to the heat of the welding, and that's the only thing I can think of that's caused this kind of an issue. I'll have a look at the tool in close-up very shortly, and we'll show you the tip of it. It has got some damage on it, but that's what I think has happened anyway. And I'll show you this, the sort of the geometry of this absolute mess in a minute when I've cut it in half. What I want to show you now is if we get the gauge, we can show you the tool and what's actually happened to the tool. It's not very happy at all. The angle looks reasonable, although I think that the angle on the right hand side as we look at it there has suffered somewhat. It's become more of a curve, and the tip of the tool has definitely been abraded or eroded. You can see it doesn't fit into the 5 TPI slot anymore, gauge anymore. It's a better fit in the 6 now, or it doesn't quite go, but it almost wants to. But you can see that from previously, when we had a nice fit in the 5, it's definitely not fitting in there correctly now. It's somewhere in between the 5 and the 6 now. So it would appear that this tip has suffered badly from attempting to cut that thread, and considering that it was only in 6082 aluminium, which is about 90 Brunel for hardness, I suspect that something's gone wrong with this piece of carbide. And the only thing that I can think of that would have done that would have been the heat from welding this bar onto here to try and stiffen this up. So basically, this kind of whole tool has been a complete failure, really. And perhaps I should have suspected as much from the outset. The amount I had to thin it down to get it into the hole was just ridiculous, really. And that meant I then had to weld this bar on, which hasn't done any good. Just the whole idea of taking a brazed carbide tool and trying to modify it to do this job has just fallen on its backside. And you can actually get solid carbide threading tools for Acme. I was looking at a company in the UK, here in the UK, called Pro Tools, and they do one, and they are quite spendy. But I think for the amount of time that I've wasted on this now, I think I'm going to probably just buy one and get the job done, because I mean, really, this is the purpose of the whole point of making this of the test. The test piece was to make sure that this worked. Because can you imagine how frustrating it would have been to have done that in the bronze? I mean, this was frustrating enough, but I think I probably would have been on the end of a rope if I'd done that in the bronze. I mean, it's entirely my own fault. But, you know, you live and learn, and nothing ventured, nothing gained, as they say. But I have, you know, I've wasted quite a lot of time. Now, the other thing I did mention before was I've got this this tip that I bought, and I could use this. The only problem that I've got with this is trying to make a holder for it that will actually fit into the bore. For me to get this into play to do the job, I would be running into the same sort of issues as I had with this. And when this was actually in the bore doing the job, you couldn't see very well on the bit of footage that I've got. But as it got deeper in and started to depth the thread, it was really bending. The torsion on it was really twisting it round. So I think I would be hard pressed to get this in to do a proper job on center height rather. I would really be sort of the idea that I would have would be taking something like this and milling a pocket into it for this to fit into like this. But then I would have to relieve so much of the base of this and the side that I would probably be, and for such a length as well to get in the depth of that that nut, that I would be running into the same kind of issues that that I've had with this thing, rather. So I think perhaps what I need to do is just basically bite the bullet and buy the proper tool for the job. Yeah, so we'll have a closer look at this now and see if we can see any more clues as to what's actually gone wrong with it. Okay, so I've zoomed in on the tool now, about 5 times zoom, and we can see that the 14.5 degree angle on the right hand side of the tool certainly seems to have lost some of its definition. It's more of a sort of a curve in this area here, and it does seem to have a radius to it. And as we rotate the tool towards the tip, I'll try and keep it in focus if I can, we can see that there's definitely some damage on the tip that's been doing the cutting. There's some abrasion there, or we can see a mark on it. Now this side here, because of the angle of the top slide being at 14.5 degrees, this is the side that was doing all the cutting. I'll try and get that to focus a little bit better. So you can see there's definitely some damage on the tip. And that tends to lend weight to this idea that the carbide has become softened, or certainly lost some of its hardness from the heat of the welding. when I welded that bar onto it, as I mentioned earlier. You can see there the braze is intact, and I'm somewhat perplexed because I would have expected the braze to have melted and the tip to have fallen off if any heat damage was going to occur, but it looks as if it has done something to the carbide. I've searched on the internet, as I've said, and I can't really find any references to heat damaging carbide to that extent. I mean, I think you can take them to almost a cherry red and they're fine. And it didn't get that hot when I was welding it, but it's obviously not done it any good at all, the welding, and that would seem to be the reason why this has been unsuccessful. That's a better view there, I think, of that damage. So there we go. Looks like we're going to have a rethink, certainly. Okay, so I'll put a hacksaw through the test nut. I mean, to call it a nut is actually, you know, it's charitable, really. It's just absolutely horrendous. So I'll try and bring the pointer in. There it is. We've got zoomed in about 4 times. So we can see here the depth thing's gone awry. We've got like almost two different depths here, and this one's offset. And then we can see the flanks here where, try and get it to focus properly. The tool's not been cutting, it's just been tearing. And that's particularly horrendous there. And I don't have an Acme thread gauge, but I can show you if I use the carbide insert as a, I'll try and bring it into shot. If I use the carbide insert as a gauge, just get it so that you can see it properly. You can see there, look, and it's just ridiculous. It's completely shot. I mean, there's like almost 2 different root widths. I don't know what's happened there. Obviously the tool's completely lost its edge and it's changed, the geometry of the tool is altered to the extent that it's actually caused this this issue. So wholly unsatisfactory would be a charitable way of putting it, I suppose. I'm not going to lie to you, I'm disappointed at this, but at the end of the day, you live and learn. This was the reason for making a test nut and trying the tool out. The tool's been a complete failure. That's the only conclusion that I can come to from this. I think the design of it was flawed from the outset, and I should have just ground a piece of high-speed steel or carbide and inserted it into a bar. That would have done a much better job, I think. And I may still do that, but as I've mentioned, I'm looking at purchasing a solid carbide threading tool just to get this job done and get it done properly and reliably. So there you go. Yeah, I mean, it doesn't look too bad when you look at it from that angle, but it's just these roots are so wide. The depth thing's completely gone awry. You can see there, look, almost where it's started to depth it twice, and this bit here is about the right width, but then it's gone out to here, which is very bizarre. But there we go. We'll keep trying, and I probably won't get it done now because I haven't got much time left at home, which I'll explain about in a minute, but we will get there in the end. Okay people, so that's the end of part B, which was quite clearly not the outcome that I was hoping for or that I wanted, but never mind, we'll soldier on. Now, as those of you who know me personally will know, I work away from home, usually for 4 to 6 weeks at a time. I've had an extended period of leave that was due to me because of the commitments that I made during the COVID pandemic. So I've been at home for quite a long time now, and I've had a great deal of time to spend in the workshop and get quite a lot of the project moved forward and other things done, which has led me to be able to produce quite a few videos for you guys to watch. And it's also led to me building up my subscription rate. So thank you very much to everyone who's taken an interest in my channel and has subscribed to me over the past few months. I'd like to thank especially a gentleman who goes by the screen name of Fast Druid, who has given me a lot of really useful, good information about the Harrison mills. I'd also like to thank Jack Body as well for all his really good feedback and the email that he sent to me with some excellent comments and feedback. Thanks also to Mitch Lees for the use of his workshop and for all his advice and for his help. And I'd also like to thank Richard Oakley as well for his, as ever, his unstinting support to me, and his help has always been there for years, and hopefully always will be. So I'm going away to work next week, which means that I won't have any more time really in the workshop between now and when I go away, and I'll be away for about 4 weeks, so you won't have any more practical updates from me or any more videos. Now, I appreciate that a lot of channels like to post like once a week or maybe even twice a month, something like that. I can't do that because of my lifestyle, the way I work. I'm away for long periods at a time, and then I'm home for a period of time. So I do hope you keep faith with the channel and keep a lookout for when I do post again. I'm not just going to be posting for the sake of it. If I've got something interesting to show you and something that I've done, then I'll make a video and I'll post it up for you. So until we see each other again, and until I make you another video, I hope you all take care of yourselves and have a great time. And I'll see you in about 4 weeks from now. Okay, take it easy, and bye for now.